Okay, so this is the last video of the session 4. I just opened the dataset in JASP. So let's have a quick look at the data. This is a dataset from a recently published study of mine and other colleagues about psychological characteristics of BDSM practitioners and non-practitioners. It has been recently published in a pretty good journal, so we are happy about that. So let's get some descriptive statistics going on. So I'm sorry for the Spanish labels of the variables, but I will explain every variable that we will use. Okay, so let's have a quick look on the descriptive ones. In demographics, for example, let's have, as you can see here, we have mainly young individuals. Let's have this variable of gender for simplicity. As you can see here, we have more women than men, typical thing in psychology samples. And we have sexual orientation measured as independent from their gender. So we have androsexual and curious. These are people attracted by mostly men. Bisexual or pansexual or plurisexuals, men, women, and everything in between. Gynosexual and curious and gynosexuals, who are persons attracted for mostly feminine persons or women, and asexual individuals. Okay, so we have mostly bisexuals and also gynosexuals and androsexuals, so that's okay, I guess. And we have also other variables, other interesting variables with psychological self-reports, like the Big Five here. Then, as you can see, let's remove these variables. We have mostly normal distributions regarding the 5 facets of the or the 5 traits. We also have this adult attachment style questionnaire. Conf is confidence, which is a proxy for secure attachment. Relationship and secondary and is a proxy for avoidant attachment. And also we have need for approval and preoccupation. There are subscales for anxious attachment. Okay. So as you can see here, we also have kind of normal distributions. We also have rejection sensitivity scales with one from anxiety to of rejection and actions towards avoiding rejection. And also finally we have the WHO-5 scale of well-being. So as you can see here, we have like some kind of self-report variables and also some demographics that can be interesting to do some analysis. Okay, so let's have a look on Bayesian one sample t-test. For example, let's have age as a variable. And let's say, for example, that we put 30 as a criterion. As you can see here, we have the Bayesian factor or the Bayes factor as really, really high. So it seems that it's not 30, or at least the evidence suggests strongly that it's not 30. If we change it as greater than 30, it's also supporting H1. Okay. And also if we put it as less than 30, we have super strong support against this hypothesis. So I will leave it as two-sided. And we can ask for the prior and posterior plots. That will be here. As you can see, we have a very non-informative prior and a very strong data likelihood that creates a posterior that is it's very narrow. We can ask also for robustness analysis and sequential analysis with a robustness check. I will also have some descriptives with Renker plots. And let's have a quick look. We have some progress bar, and there you go. We have the robustness analysis signals that we have a very robust finding because the the most informative prior that we can imagine in the Cauchy distribution would signal us that we have like at least 1000 as a bias factor. So that's pretty strong support, and everything we can do in that direction, even with super non-informative priors, will be around 10,000 as a bias factor. So that's okay. That's a very cool thing to have. It's very robust, this conclusion. And here is the sequential analysis. And as you can see here, we have a super strong support in some part of the sample, and then it goes down towards basically nothing, stays even against the hypothesis, and then scales up a bit. So maybe there are some confounders over there, and maybe sorting the sample regarding some third variable and repeating this analysis could illuminate us about maybe these potential confounders, because as you can see here, there is no straight tendency, because it goes really up to 500 participants, and then goes down and stays down until more or less 1500 participants, and then goes up again. So it's kind of strange. It's kind of non-stable. And finally, we have this credibility interval plot with the point estimate, and here is the descriptive information. As you can see here, we have a mean around 30 something, more or less. So yeah, this is like a typical one sample t-test in Bayesian way. Let's have a look to binomial tests. Let's have a binary variable, for example, binary gender or binarized gender. This is a non-informative prior, like 0.5. So let's ask for sequential analysis, plot some prior and posterior. So here is our prior and posterior for women with its sequential analysis. As you can see here, this is pretty stable. And also for men, also pretty stable and pretty strong. So as you can see here, more women than men, less than 0.5. So that's how you can do a binomial test. What happens if I say 0.6 for women? Then the proportions will change. And as you can see here now, we have for men more or less the same scenario, but women now is changed, because we have 0.6, that was the criterion, and now we have a really strong posterior with just overlapping with 0.6, and now the sequential analysis goes down and down and down. Okay, so it's kind of different. So if you start getting informative priors, remember that the situation will change. So that's why it's so important to have more than one reason and a really thorough and rational decision on why the priors are going to be those that you choose. Okay, let's go to the multinomial test, for example, and get sexual orientation, for example. Let's have it non-informative and ask for proportions and the descriptive plot. And here are our proportions with their credible intervals, and the priors could be like this, everything is equal, or you can specify which proportions do you expect or which frequencies do you expect. Okay, so now we will move to independent samples t-test, for example, and let's see if there's a difference between for example, grouping variable by gender. Let's ask for prior, posterior, robustness, sequential, and array count plot, for example. And also let's have a look about neuroticism, the trait of neuroticism. Okay, now we have the prior and the posterior. Now the robustness is going to be here. And as you can see here, it's pretty robust finding, because even with super informative priors, we are around 10, a lot of numbers, right? 10 up to 12, or exponent of 12 at minimum. And we have here a pretty solid example, a pretty solid tendency towards having stronger and stronger and stronger and stronger support. So that's pretty good. And as you can see here, it seems that there is a difference in gender. So we have pretty much very strong support against null hypothesis. And you can see here that the effect size here will be around 0.4, 0.3, more or less 0.42, like around 0.3 at 0.5. And you can be very sure about that. Okay, I will not do paired sample status because this dataset doesn't allow it. So I will go for Bayesian correlations right now. There you go, Bayesian correlation. And let's have a look, for example, at the whole big five, the relationship between them. Excuse me. Let's have a look over there. Now we have the Pearson's R and their respective bias factors. You can also choose Kendall's Taubi if you like it. And you can also show it as pairwise. You can use these 3-star systems that is over here, but I wouldn't recommend it because, you know, like, that's not very Bayesian way of thinking unless you have a lot of correlations that you need to filter. You can also ask for credible intervals if you like, and you can plot them as a correlation matrix with posteriors and densities. And here you can adjust the prior width of the beta parameter in the beta distribution, right? So that's pretty much okay because then you can make it a more informative sample. And here we have a pretty much very informative plot of all of the scatter plots available, our densities and histograms of our variables, and also the posterior distributions of all of the Bayesian inferences that are going on. However, we can be more specific and, for example, select just one pair, neuroticism and extroversion, for example, and ask for robustness analysis, prior and posterior, and sequential analysis. And now it will have, or it will create a specific pair of neuroticism and extroversion. As you can see here, there's a negative tendency. Now it will show our prior and posterior. As you can see here, we were expecting non-informative priors, so around 0, and plain distribution. And now we have a pretty much intense support towards a negative correlation of 0.40 with a credible interval. And here we have a pretty stable and a very clear sequential analysis. And also the robustness analysis, as you can see here, seems to be super robust and super stable. That is typical in correlations, right? Okay, so that's Bayesian correlations. Let's have a look at the contingency tables from a Bayesian way. For example, let's pick up gender in columns and also being a practitioner of BDSM or not. For example, here we have a 2x2 table. We have women and men, practitioner and non-practitioners, and here we can adjust the sample that we need, for example Poisson, hypergeometric, or whatever we need. Because we have a 2x2 table, we can ask for log odds ratio, and also we can establish a prior concentration here. And for example, let's pick the hypergeometric, and you can see here that is not available. And finally, we can select the percentages if you want them, and also other options here of sorting. And as you can see here, we have the bias factor of the contingency table, the log odds ratio, and also the posterior of the log odds ratio plot with the bias factor and the median. Okay, so those are basic tests. Now we can have a Bayesian ANOVA, for example. Let's have a pretty simple example, like gender and being a practitioner or not, with their interaction, and see if there are differences in neuroticism. I know this is the frequentist ANOVA, Bayesian ANOVA. There you go. So gender binary and being practitioner or not. Now we have neuroticism here. And I can ask, as you can see here, we also have non-informative priors, so prior probability is equal for all of the models. And now we have a model counting on with data, as you can see here, gender binary, and being a practitioner of BDSM is now the strongest model with the highest probability with a bias factor of 15. Okay, so that's okay. I can also ask for the model average R squared, as the estimates of the models, and also the estimates of model things. I also can have the model average posteriors, the QQ plots, and the posterior R squared, all in tables. Okay, and group levels in single plot. Okay, now we have the interaction, the two main effects. Remember that interaction should not be included because of this. It's less likely to happen, so that's okay. Now we have all of the effects that we need here, and we also can do some post hoc tests. For example, let's have this. Now let's have some descriptive plots, like something like this, with credible intervals and whatever, and some radical plots, for example, separate plots, horizontal display, etc. And additional options here, you can pick your prior, for example, uniform priors, beta binomial, Wilson, Castillo, etc. You can also adjust the MCMC technical output, set the seed, choose an integration method, and here we have our thingies. For example, here is a post-hoc comparison only for gender. Here are the plots that we asked for, as you can see here, and also you can see here. Okay, so that's a Bayesian ANOVA. And finally, we will do a Bayesian regression, linear regression. For example, let's predict well-being, for example, the WHO5, with neuroticism and the other ones of the big five. As you can see here, the models are sorted as the highest posterior, and we have a highest posterior of only counting neuroticism, extroversion, and conscientiousness. So it seems that agreeableness and openness are not relevant regarding well-being. And the best model is to only have these three variables with by far a stronger bias factor. Okay, so I can have a posterior summary, a plot of coefficients. Let's omit the intercept because we're not really interested in that. And we can compare to the best model or compare to the null model if we want to. So as you can see here, we have a posterior coefficients of all of our predictors, and remember that two of them were not relevant. So this is because here is selected as model average. Model average means that it will have the effects of all of the models, make an average for each predictor, and then plot them. But we can make the median model instead of the average, the most complex model with a saturated model, or the best model. Let's have the best model. And then we will have this: neuroticism, extroversion, and conscientiousness with their respective effects and credible intervals. Now we can do things to this model if we want to. In the plots, we can plot the inclusion probabilities, the marginal posteriors, QQ plots, residuals, and fitted, etc. And we can do it also with log posterior odds and modulus probabilities, etc. Finally, in advanced options, we can also select the prior. We can also select the sampling method, for example, Bayesian adaptive sample, or MCMC if we like, how many steps we want, the seed we want, and also if the prior of the criteria of the prior will be based on any of these indices, okay? So now we have these residuals versus fitted. As we can see here, there is no significant relation. Now the inclusion probabilities, as you can see here, neuroticism, extraversion, and conscientiousness are above the prior. The QQ plot shows no problems, and we also have the posterior distributions. This is the intercept, this is neuroticism, like minus 0.5, density of the extroversion, openness, agreeableness, and conscientiousness. And that's basically it. Those are quick examples on how to do a Bayesian standard test. with all of these possibilities. There are lots of more possibilities. For example, repeated measures, ANOVAs, ANCOVAs, mixed models, generalized linear models, logistic regressions. We can do A/B tests, log linear regressions, and more things. Okay, but I think this is a good starter kit if you want to do some basic tests and then start digging about more Bayesian ways on doing statistical inference.